Hello students, I hope you all are doing great. So in this video, we will be gonna learning rolling motion in an incline plane. Okay. So first of all, here is our incline at an angle theta, and this is our the general mass or round object. Let us say it may be a ring, it may be a disc, it may be a cylinder, a solid or a hollow, or a sphere. Okay, so let us first what do you say? Let us first demonstrate the whole scenario what is happening over here. So this is our sphere. Let us say for this case, which is of mass m and radius r. This is the radius, and let me draw the free body diagram for this object. So first of all, we'll be drawing an mg force. Wait a minute. So first we will be drawing an mg force. Next, what will be there? A normal contact force due to the inclined plane perpendicular to the incline, which is n, and very important, the direction of friction. So you will always have to remember the friction on this point of contact will be in this direction, and this friction is static for pure rolling. Okay, this is very important factor to learn for the exam like JE or NEET, etc. Now we can break this force mg in two directions as per the incline. One will be along the incline, which is what, mg sine theta, right? One will be perpendicular to the incline, which will be mg cos theta, right? Now what happens is, in rolling motion, there are two types of motion uh, which is together happening. It is very interesting. First one is, we say, translational motion, and the next one is rotational motion. And for your information, when you comes to this topic, I assume that everyone has completed the rectilinear and the rotational part. So we will be using those concepts. So those concepts must be strong for this topic specifically. Okay. So this rolling motion is in two parts. It is translational and rotational together. Okay. Now let me define some very important formulas that are, let us say, conditions which is important for studying these topics and solving these cons questions on rolling. So one important key formula is moment of inertia, which we often write as I, and one key formula for our this topic is gonna be I equals, we will be writing kmr square. Now what is k here? This is a constant which varies as per our this round object. Whatever this round object will be, the k will vary. Now let me take an example for this. If if uh, if our object is ring, okay, then the k will be 1, so that moment of inertia will be mr square. If k will be, if the object will be disk, then k is gonna be what, half. This we study in the moment of inertia in the early part of rotational dynamics. If we, our object is Solid cylinder, solid cylinder, our K constant will again gonna be 1 by 2. Okay. If our object is a solid sphere, our K constant is gonna be, sorry, is gonna be 2 upon 5. This is an important formula for you in this topic. Uh, I would recommend to remember this just to make the concept easier. Okay. Now let us move on. So, what are the conditions for this rolling motion? First one is we'll be writing the net motion in a formula which will be F net is ma. If this object is moving in downward direction with an acceleration a, we will be writing a formula or a condition for F net equals to ma. Now what it gonna be in the direction of the motion? There are only one force uh, by the object, which is mg sine theta, because of its mass, and the friction in opposite direction. So if we take this direction as positive, our F net, the left hand side of this equation, will be mg sine theta minus F equals to ma. This is our one of the condition we should have in keeping in mind to study this concept. And the second one will be the torque about the center of mass, which is I alpha. Okay. Now, what is the torque of this body around the center of mass? We will be taking the torque due to the force of friction. Okay. This is very important. So, what this torque is gonna be? F into R, simply equals Ia. Now, let me conclude a very simple condition or equation which you will keep in mind to solve the concepts and the PYQs of J coming in an exam very easily. Now, what this I gonna be? From our formula, our we studied earlier, is I equals kmr square. Okay. Now we can write I alpha as kmr square into alpha. And what alpha is? Alpha is the angular acceleration. So we can write kmr square into a upon r. R is the radius and a is the acceleration. Okay. Now we will solve this equation and very easily we can get the what formula for friction, which is F equals kma. Okay. This is the second condition we should keep in mind to study this topic. Okay. Now, focusing on the concept, we are often asked in exams, uh, three types of conditions are often asked in this topic. First one is what are the acceleration and velocity in this rolling. So you will be asked about the motion of bodies, in which you can the question can ask acceleration or to find the velocities. And the second case you will be asked friction. Okay. And the third case, very important, is the minimum coefficient of friction to be pure rolling. Okay. Now, very important, if we find the acceleration. If you are assumed to find the acceleration, you can see from the first formula and the second formula we derive, we can easily get the acceleration part. How? Let me show you. This is our first equation, this is our second equation. So using 1 and 2, we can find acceleration. How? So let me put the k and a into this equation. So it is gonna be mg sine theta minus k and a equals ma. M will be cancelled, and what we get? A equals g sine theta upon 1 by r, right? Sorry, sorry for the huh, g sine theta upon 1 by r, right? Let us remember this third equation, or I would say not remember, I would say remember the conditions logically so that you could just instantly derive and find the thing what is asked you, right? And if friction is asked, you can have the this applied directly in your concept, right? The next thing is minimum concept of minimum coefficient of friction. Now what this gonna be is very exciting. Okay, the coefficient of friction for pure rolling. If we say condition for pure rolling or no slipping, the friction for pure rolling should be always minimum or less than or equal to F max. And what is F max? Mu into n, the normal, right? And if we write the F friction for pure rolling, it is K and A, we just derived here, and it should be less than or equals to mu and what is n? N is mg cos theta, and here is equal to mg cos theta, right? So it should be less than mg cos theta, right? And from here you can derive the equation for mu, which should be greater than or equal to k tan theta upon 1 plus k. These are one of the important results you can remember how it derive, how it comes to solve our questions easily, right? Now, one more important thing. If we say that our pure rolling friction should be less than or equal to F max, then if the body is not in pure rolling, if not in pure rolling, let me write this some different colors. If not pure rolling, okay, then it becomes so easy that F is equals to mu n, and what is n? Mu mg cos theta, okay, right? So what we have seen over here, first the free body diagram making, the rolling motion is the translation motion and rotational motion together, the moment of inertia, key formula to note, and two conditions for the motion. First one is we will be writing the equation for motion F net equals to ma, then the torque, and we have derived some equations important for your concepts. Okay, so using the same things we derived here, we will be solving some of the easiest concept based questions in J. Okay,